Hi guys, my name is Monica and today I'm going to show you how to solve problems using Newton's second law. Now before we look at Newton's second law, I think it would be good for us to go back to find out what Newton's first law was all about. Now let's suppose we have a mass that is placed on a horizontal surface. This mass down here will stay stationary because there is no net force acting on it. Now another case you can look at is the second case. We have got a body that's already moving with a certain velocity. It will continue to move with that same velocity and in the same direction if there is no net force exerted on it. So going back to case 1, over here, you can see that this object remains stationary because there is no net force acting on it, so it cannot accelerate from rest. Similarly, for this case down here, case 2, the object continues to move with the same speed in the same direction as there is no net force acting on it as well. So, what Newton's first law says is that if there is no net force acting on the body, so the body will continue to stay in the state of rest or of uniform motion unless it is compelled to change that state by a net force impressed upon it. So in essence, what it means is that for Newton's first law to be obeyed, the forces must be balanced. That means there is no unbalanced force, or you can say the resultant force is 0, or you can also say that the net force is 0. All these three talk about the same thing. There is no net force acting on the body. So if there is no net force acting on the body, Newton's first law of motion is obeyed. Now what happens if we have a unbalanced force, a situation where we have an unbalanced force? We take this mass for example. So originally it was stationary, then it starts to move. It starts to move and eventually it starts to stop. It stops. So, or another case where this ball goes round in a circle. So we are going to examine all these three cases one at a time. The first case, case 1. So as we said, the ball was stationary originally. That means the speed was 0 originally. Then it starts to move. That means it will accelerate from 0 speed to a certain speed. So to do that, there must be a net force that causes it to start to move. Now in case 2, the body was moving with a particular speed, a certain speed, and eventually it stops here. So we say that this body decelerates, and that deceleration is caused by a net force that was acting on this ball to cause it to decelerate. So there's again a presence of net force. Now what about case number 3? So let's look at case number 3. So here we go. So case number 3, the net force causes this ball to change direction all the time. So as a result of this, there is an acceleration that's acting towards the center of the circle. So in all these three cases, case 1, case 2, and case 3, there is a net force that causes the body to accelerate or to decelerate. So there is a net force that causes the object to either accelerate or decelerate. So you can put it mathematically in a formula form: acceleration equals to the net force divided by mass. So what it means here is, if you can put it in just this very simplified formula, acceleration is net force divided by mass, meaning that the acceleration of the body is directly proportional to the net force acting on the body and inversely proportional to the mass of the body. So let me show you an example on how Newton's second law can be used. So a very typical example is this. Okay, before we look at the example, let's just summarize Newton's second law. Now, Newton's second law states that the acceleration of an object is directly proportional to the net force acting on the object and is in the same direction as the net force and is inversely proportional to the mass of the body. So that putting into a formula form looks like this. Sometimes people prefer to put it in a single line where the net force is mass times acceleration. Either way is okay, yeah, as long as you know what you are doing. So as I said just now, we are going to try an example that reads something like this. A tractor of mass 100 kg pulls a cart of mass 45 kg. The tractor experiences a frictional force of 40 newtons while the cart experiences a frictional force of 20 newtons. So you've got things to find. Yeah, the first one is to find the force exerted on the cart by the rope when the tractor accelerates at 2 meters per second squared. And number two, the driving force of the tractor and the tractor when the tractor accelerates at 2 meters per second squared. So the first thing you need to do is to draw a diagram depicting the situation. So we have got a tractor here pulling a cart. Yeah, a cart, there's a rope connecting them. And so of course you have to put in the forces. Yeah, so the second step is to indicate the forces acting on each of the bodies. So we start off with the tractor. Yeah, so we look at the forces acting on the tractor. So the first force will be the driving force that comes from the engine of the tractor. And we have got another force that we can put at the tractor here, which is the tension. The tension is the force exerted on the tractor by the rope. Yeah, so it's pointing in this direction. And one more force that is mentioned in the question is the frictional force. Yeah, so the frictional force on the tractor is 40 newtons going in the opposite direction to the direction of motion. So, okay, so these are the three forces acting on the tractor. Let's go on to the cart. Now, for the cart, so we have got the tension. Yeah, this is a tension, which is the force exerted on the cart by the rope. And we have also got this thing called the frictional force acting on the cart. So, frictional force, as mentioned in the question, is 20 newtons. Now, since these two bodies are connected together, both of them will experience the same acceleration. Since they said that the acceleration of the tractor is 2 meters per second squared, so what it means is that the acceleration of the cart must also be 2 meters per second squared. So the cart is 2 meters per second, so the tractor is also 2 meters per second squared. So now we have finished step 2, in which we have indicated forces acting on each of the bodies. Now the third step is to apply Newton's second law, which says that the net force is proportional to or is equals to the mass of the body multiplied by the acceleration. So we would want to look at the cart first. So looking at the cart, yeah, so it's moving in this direction. So this force is greater than the force pointing towards the left. So we have got the tension minus 20 newtons. So we will have tension minus 20 newtons, which is the frictional force on the cart. So this would form the net force. Yeah. So the net force down here is equals to the mass times the acceleration. So that is what Newton's second law is all about. So of course, the next step, you just substitute the values in, and eventually you get the tension, which is the force exerted on the cart by the rope, to be 110 newtons. So the next step now is to look at the tractor. So the tractor is exerted by these three forces: the driving force, the tension, and the frictional force. So since it's accelerating in this direction, what it tells me is that all forces pointing to the right will be greater than all forces pointing to the left. So in other words, what we have here is that the net force, which comprises of this, the forward force, which is the driving force, minus the tension, minus the frictional force, that forms the net force acting on the tractor, is equals to the mass times the acceleration. So again, Newton's second law is applied in this equation. So the next step now is to fit in all the numbers. So we have got the tension, which we have calculated in part 1, the frictional force exerted on the tractor, 40 newtons, mass of the tractor is 100 kg, and the acceleration is 2 meters per second squared. So therefore, my driving force then is 350 newtons. Well, if you find this video useful, please visit my website at www.physicstutionspecialist.com to learn more about how to solve problems involving Newton's second law and other school physics problems. Thank you for watching. Bye.